بسم الله والصلاة والسلام على رسول الله نبينا محمد وعلى آله وصحبه أجمعين. حياكم الله أيها الأخوة والأخوات في سلسلة ويبينارات الجمعية الكيميائية السعودية. محاضرة اليوم بعنوان Basic of Solid Phase Extraction of Heavy Metals، يقدمها سعادة الأستاذ الدكتور مصطفي سويلاك، أستاذ الكيمياء التحليلية بجامعة ارجيس. العالم سويلاك متخصص في تطوير أبحاث الفصل والاستخلاص المعادن والمواد العضوية من العينات البيئية، والتي تشمل المياه والتربة والأغذية والأدوية ومواد التجميل، وبالأخص الطرق التي تدعم أبحاث الكيمياء الخضراء واستخدام المذيبات الآمنة والمواد النانوية المتقدمة لتحسين كفاءة الطرق التحليلية. الدكتور سويلاك له ما يزيد عن 600 بحث منشور في مجلات محكمة دوليا، وبلغ عدد الاستشهاد بأبحاثه 29,000 استشهاد، وبلغ معامل التأثير له 98. ويعتبر بروفسور سويلاك من الباحثين الهايلي سايتد المعروفين في مجالهم دوليا. بروفسور سويلاك من المتعاونين مع جامعة الملك سعود منذ أكثر من 8 سنوات على برنامج أستاذ زائر وبرنامج الشراكة العلمية الدولية. فباسم الجمعية الكيميائية السعودية وقسم الكيمياء وبرنامج الشراكة العلمية الدولية يسرنا الترحيب بالبروفسور سويلاك. On behalf of Saudi Chemical Society and Department of Chemistry, we are glad to invite Dr. Sawilak. تفضل دكتور. تفضل دكتور.
السلام
You can
عليكم.
talk.
Can I start?
Yes, doctor, go ahead.
Bismillahirrahmanirrahim. Selamun alaikum from Turkey, from Kayseri. I'm Dr. Mustapha Soylak. I'm from Erciyes University. Now I will start to my lecture titled Basics of Solid Phase Microextraction of Trace Metal Ions. Firstly, I want to start trace metal ions. Trace metal ions plays very important positive and negative roles in our life. Especially some of them are dangerous for our life, some of them are essential for our life. Due to these points, their importance, we should learn a lot of things about them. This is a Turkish slide, but everyone can understand this. Smoke is very dangerous, and also cigarette smoking is very problematic for our life, and cigarette contains also some of trace metal ions, including arsenic, including cadmium, including nickel. And another example for trace metal ions is mercury. Also, mercury is a very dangerous element for human, and also the determination of mercury from environmental samples, also in fish samples, is very important. The level of mercury in some fishes may be found very high level for dangerous levels for human. Another example, this is also a Turkish slide, selenium. Selenium is, as a trace element, is very important. Maybe in Turkey you can find some egg. It contains selenium because of selenium. It's very essential elements for to healthy life, and also the feeds of chickens contains higher amounts of selenium than normal eggs. And also you can buy these kinds of eggs from the markets. Another dangerous element is arsenic. Everyone knows, even not chemists, everyone knows arsenic is a big problem in our life, especially arsenic levels in drinking water, in other water samples is big problem, especially in Bangladesh, in India, in Pakistan. Higher levels of arsenic in waters maybe has a lot of problematic things in human life, like black food diseases and others. You can see the high arsenic contents of water samples, how can causes in our legs and other parts of humans. And also, if you are rich people, you can find arsenic-free water from the markets, but not if you are not rich people, you should drink the arsenic contains waters. Due to these points, maybe determination of arsenic is another important point for our life. These examples is how they are essential or how they are dangerous in our life for trace metal ions. Due to these points, we should determine them by using accurate and precise determination methods in analytical chemistry studies. But there is some problems in these kinds of determinations due to their levels are very lower than detection limits of instruments. You should find another instruments which you can determine them with lower detection limits. But another big problem is in this kinds of determination is large amounts of matrix components of samples, especially for us, for analytical chemists, especially seawater, urine, and other high saline content samples is very big problem in the determination of trace metal ions in water samples, these kinds of samples, and you should reduce your matrix before the determination, and also complexity of matrix, sample matrix, and speciation of chemical forms of the analyte is another problems in these kinds of determination. And so generally solution is for these kinds of problems is to find a suitable instrument or to find a suitable methodology. If you are rich, if you work in a rich laboratory which has a lot of instrumentation, you can find some new instruments, some accurate instruments, some lower detection limits instruments like ICP-MS for trace metal ions. But even ICP-MS, maybe for higher saline samples, the separation is necessary. Due to these points, we suggest that pre-concentration and usage of pre-concentration and separation methods in the determination, before the determination of trace metal ions from environmental samples, especially in water samples, in highly saline samples, including seawater and urine. These kinds of methodologies, maybe we have a lot of methodologies like solid phase extraction, co-precipitation, cloud point extraction, solvent extraction, classical solvent extraction, electrodeposition, atomic traps, micro extraction techniques, and others. Today, I want to talk about especially on solid phase extraction of trace metal ions. In the solid phase extraction of metal ions, the methodology is very simple, very sensitive, very fast, economic, and also we can reach large pre-concentration factors, and the methodology is suitable. The methodology is very simple, and also suitability for automation is possible. In this kinds of works, we use generally new kinds of adsorbents. The adsorbents used in solid phase extraction of trace metal ions has some characteristics, like porosity having a large specific surface area, low blank, high chemical and mechanical stability, fast kinetics of absorption and desorption, reversible adsorption, high selectivity, and high recovery rates is the characteristic of our adsorbents should be. In this kinds of solid phase extractions, in the beginning activated carbon, maybe new activated carbons, or also still popular nowadays, also silica gel, or synthetic polymers like amberlite, XID resins, ambersorb resins, some biosorbents, imprinting polymers, carbon nanotubes, graphene, and their nanocomposites could be used for the solid phase extraction of trace metal ions. Now, I want to talk about new materials, nano-sized materials for solid phase extraction of trace metal ions. You know that nanotechnology in our life and also nanomaterials could be used in the various area of science, and especially in as an adsorbent, they can use in solid phase extraction studies. Everyone knows nanomaterials approximately at the size range of 1 to 100 nanometer, and this area maybe we have nanopores, dendrimers, nanotubes, quantum dots, and nanoshells. Also, these kinds of materials can be classified as zero-dimensional, one-dimensional, two-dimensional, and three-dimensional. And also one-dimensional nanomaterials, carbon nanotubes, inorganic nanotubes, and nanowires, and two-dimensional nanofibers, and three-dimensional, we can give an example, mesopores, nanoparticles, magnetic nanoparticles, and others. You can see from this slide fluorine, single-volt carbon nanotube, multi-volt carbon nanotubes, and graphene. At the end, I will say some things about graphene. Graphene is very popular, is also in this area. Maybe some inorganic nanomaterials like metal nanotubes, natural zeolites, some organic nanomaterials, including carbon nanotubes, graphene, and others, and also some biological nanomaterials can be used for the solid phase extraction of trace metal ions, like bacteria, nanocellulose, nanoorganisms, and others. Also, their hybrid materials could be used for these purposes. And also nanomaterials in sample preparation by using solid phase extraction studies. We can use a lot of nanopores materials, as we talked before. They could be carbon nanoparticles, metal or metal oxides, but nowadays also metal organic frameworks, covalent organic frameworks are very, very most, and JOF is very, very important in these kinds of studies. Firstly, I want to give some examples. And firstly, I want to start carbon nanotubes. Approximately 10 years or 12 years ago, we start to work with carbon nanotubes, and we still working on carbon nanotubes today for solid phase extraction of trace metal ions. I am talking about today only trace metal ions, pre-concentration and separation. But another part of this lecture, maybe next time, I will talk the pre-concentration and separation of organic trace organic materials. But today, I will cover only trace metal ions. Carbon nanotubes, as everyone knows, that they are one of the most commonly used building blocks of nanotechnology, with 100 times the tensile strength of steel, thermal conductivity better than all, but put the purest diamond and electroconductivity similar to copper, and also it has very good adsorption properties, including very stable for acids and bases. We can use these kinds of materials many times without any losing their adsorption properties. This is very important for us. The timeline for carbon nanotubes, their discovery approximately 30 years ago. Then it used for different purposes. At the beginning of this century, they started to use as an adsorbents, and we have started these kinds of works approximately 12 years ago, and also for their usage in trace metal ions, pre-concentration and separation. They are classified single-walled carbon nanotubes and multi-walled carbon nanotubes, and both of them can be used for solid phase extraction studies. We use also single-walled carbon nanotubes and multi-walled carbon nanotubes in our works with successful results. I will give also in next slide some examples about them. Their structure, their wonderful structure, and they have various adsorption sites. They have high surface area. Some nanotubes has over than 1,000 meters square. 1 gram has 1,000 meters square. It means that high surface area, and their adsorption sites maybe outside of the surface, interstitial channels, internal sites, external growth sites, and others. They have very high adsorption capacity due to these sites. And also carbon nanotubes can be used with different modification. For example, oxidized carbon nanotubes, modified carbon nanotubes, magnetic carbon nanotubes, or composite carbon nanotubes can be used for separation and preconcentration studies for trace metal ions. Various modification is possible. For example, in this slide you can see we can absorb metal shellacs on the surface of carbon nanotubes. For example, ammonium pyridine dithiocarboamate is very important chelating agent for us. It can be, as an example, it can be complex formation with copper and other metal ions, and these metal shellacs could be easily absorbed on the surface of non-modified carbon nanotubes, as shown in the slide. At the figure B, you can see we can modify carbon nanotubes. For example, in this modification, oxidized carbon nanotubes could be used, and oxidized carbon nanotubes easily absorbed copper-2 ions, and after absorption we use elution processes, and we can easily separate, we can easily disrupt our analysis now is copper from the surface of carbon nanotubes by using different eluting solutions. This is an example, one of example from which is worked in my lab. This is a hybrid material. It is a composite materials. It's a polyprol combined with multi-volt carbon nanotube for the solid phase extraction of lead-2 ions in water samples. We can easily prepare these materials by using different methodology, and this polymer plus carbon nanotubes we prepared, then we identified, we characterized these materials by using different instrumental techniques like scanning electron microscope, infrared spectroscopy, and others, bed surface area and others. Then we use these materials, solid phase extraction of lead ions, and we have successful results. We have quantitative results for the preconcentration and separation of lead ions by using these materials. This is how we can do this methodology is a schematic structure of this nanocomposite. One of our colleagues is working on polymer chemistry. He synthesized these materials. These new materials we used after characterization. This is the same image of these materials. First the pristine carbon nanotubes, then modified carbon nanotubes, and infrared spectrum of these materials, also thermogravimetric thermogravimetric analysis results you can see. Then we start to use it for the separation and preconcentration of lead ions by optimization stage. In the optimization of our methodology, we start with the pH of the aqueous solution, because in the adsorption pH is very important parameter for us. Maybe sometimes acidic, sometimes neutral, sometimes basic pH we use. As shown this figure, we can get quantitative results. Quantitative results means that recovery is over than 95% for lead ions at pH 5.5. Then also at pH 6. We used pH 6 as an we select pH 6 as an optimal pH. Then we continue our studies to optimize the type of eluting agent. As shown in table, we used nitric acid, we used hydrochloric acid, and we used acetic acid for this purpose with different concentrations. But we have get quantitative results with 1 molar hydrochloric acids. No, sorry, we get quantitative results with nitric acid, 1, 2, and 3 molar others acid. We cannot quantitative results. We select as for optimal eluting agents 3 molar nitric acid for desorption studies. Then the important things, another important things in our methodology is to investigate the interferic effects of matrix ions, which are related with especially high saline samples, like urine and seawater. As shown in this slide, potassium chloride, sodium, and other 1A and 2A group elements and some anions not interfere our studies. This means we can easily separate lead ions from the seawater quantitatively. Maybe the levels of some metal ions like nickel, cadmium, copper, and cobalt as an interfering ions is enough for us, because 10 ppm is very high for water samples. Due to this point, we can easily say that our methodology is could be used for high saline samples like urine and seawaters and others, like mine waters or like thermal waters. Then we start to apply our methodology for the addition recovery test for water samples, different water samples. As shown in table, our samples are a thermal water and also a mine waste water. As shown in table, we add some lead to these kinds of samples. Then we calculate, after application our methodology, we calculate the recoveries. We get quantitative results. Then we apply our methodology, 3 different water samples. One is wastewater, second is wastewater, and third one is well water. The methodology is working, the results shown in the table. Then, especially we use flame atomic absorption spectrometry for these kinds of determination, because we don't have ICP-MS and others. But how we can use this methodology, this flame atomic absorption spectrometry? We use homemade micro-injection system for flame atomic absorption spectrometry. This is very useful system for us. We can easily determine 100 microliter samples by using this system. It means that we can use very lower sample volumes for flame atomic absorption spectrometry. In in my next lectures, I will give full information about this homemade microsample injection system, because everyone knows that you cannot determine commercialized flame atomic absorption spectrometry. Your samples at least should be 0.5 milliliter. We can use this methodology only 100 microliter sample. It has very advantage methodology for us. This is another photograph of this system. This is the schematic diagram of this system. We can easily inject our sample by using micropipette to nebulizer of flame atomic absorption spectrometry. Then another wonderful material for these kinds of studies is graphene. Graphene is every chemist, every scientist knows that graphene has a wonderful material for not chemists, not physicists, in electricity, in our parts of science, very high level of usage graphene is possible because of its wonderful properties. Maybe we can give a big lecture about only graphene, but I want to say some limited things about it. The one of important things for me, it has high surface area. It means that it could be a good absorbent. Another properties of these materials, it has its mechanical properties. It's strong like a steel, it's light like aluminum, and also it's elastic like a plastic. And these properties give it is a wonderful material for solid phase extraction. Also, it is very stable materials for acids and bases. And due to these points, you can see from these slides its properties, but I don't want to talk about it. Everyone can know super fast, super strong, high visibility is possible for graphene, and flexibility, medical usage is possible, and it's very powerful materials, especially for my studies, especially for separation and pre-concentration of trace metal ions. Also, you can easily prepare graphene in your lab. Some methodologies is, you can see here, chemical vapor, electrochemical, thermal processes, and others with high efficiency. And we can also easily determine graphene and graphene oxide by using hammer method in our laboratory at Kayseri. Also, I know that it can be synthesized at King South University is also, and also many laboratories around the world. It has wonderful properties. Maybe you can easily synthesize it as shown, as I said before. And also we can easily use these materials for solid phase extraction studies, and also including magnetic solid phase extraction studies, because magnetic solid phase extraction is very popular in these 10 years, and we have also good works about them, because magnetic solid phase extraction minimized the use of additional steps of solid phase extraction, like precipitation, centrifugation, filtration, and others. And you can easily synthesize these magnetic materials with different methodologies by adding some iron compounds, some cobalt compounds to your samples, then your adsorbents, then you can easily prepare new kinds of hybrid materials for solid phase extraction studies, and you can easily separate your adsorbent by using a magnet, external magnetic field, by using a magnet. Due to this point, this is one of the schematic diagram of magnetic solid phase extraction. The method in this basics of methodology, your adsorbent should be magnetic. After preparing magnetic material, you can easily separate your adsorbent after adsorption of your analyte by using a magnet, as we are using for these proposals neodymium magnets. Then after separation by using magnet, you can discharge your liquid phase. Then you can add eluting solutions after some processes like vortexing and others. Then after eluting, you can easily separate your adsorbents from the solution. Then determination step comes. And this is the magnetic nanoparticles modified with different function groups and their process for adsorption analysis. Maybe in this kinds of adsorption, your magnetic particles maybe has hydrophobic interaction, PP and interaction, PP and dipole interaction, and others interaction is possible. As shown, as I've said that before, in these kinds of materials, we should characterize them by using infrared, NMR, SEM, TEM, thermal analysis, and also by using by determination their magnetic properties. This is another same slide about how we can do these processes by using external magnets than others. But this is a good figure for me, because at the left you can see the adsorbent which absorbs your analytes at the solution, but it was dark because it contains all adsorbents. Then after separation, we use at the right, we use magnet. Then all the adsorbents, including all the adsorbents, including also our analytes, which adsorbent on the surface of adsorbent, we can easily collect on the surface surface of the vial, and you can easily see the clear solution. At the beginning, very dark solution. At the end, very clear solution. It means that separation is very successful. This is another figures you can easily see by using magnet. We can easily separate our adsorbents from the our sample solution. And this is one of the example for you from my lab. We prepare graphene oxide modified with allylamine that contains also magnetic properties, also contains polyvinyl acetate copolymer divinylbenzene nanocomposites. We use these materials. First, we synthesize these materials, then we characterize these materials, then we use this new after characterization, we use these materials for vortex assisted magnetic solid phase extraction of some metal ions, including lead, cadmium, copper, nickel, and cobalt, with successful results. Also, all optimization states, this is the schematic structure of the nanocomposites. I am not polymeric chemistry, I'm not studying on polymeric chemistry. This study contains people working on polymer chemistry. He is synthesized these materials, we characterize, then we use for solid phase extraction studies of this. And also the stage of, all stage of the synthesized process were done our colleagues. Then after characterization by using infrared, by using the scanning electron microscope, then we use these materials for magnetic solid phase extraction studies for these metal ions. And also we get quantitative results at pH 6. Then we use different eluting solutions for the deception of our analytes from the new materials, and also nitric acid and also hydrochloric acids. We get quantitative results. We have quantitative results. We can use these eluting solutions for the desorption of our analytes from the adsorbent. Then this is the effects of interferic ions on the recoveries of our analytes. As you can see, high level of sodium, potassium, magnesium, and others not affected or the recoveries of our analytes. It means that we can use this methodology for the separation and per concentration of these ions. Then this is some analytical parameters for our methodology. We have a per concentration factor as a 40, and our relative standard deviation factors are not high, are very low, and it means that as an analytical chemist, wonderful. And also we applied our methodology, different certificated materials for the check the validation of our procedures. As shown here, we get quantitative results by using certificated reference materials. It means that we have successful results. Then we apply our methodology to some real samples like seawater, groundwater, and chili, black powder, black paper, and others. And by using additional recovery studies, as shown in table, we get quantitative results for the quantitative recovery results for all the analytes. it means that we are successful on this kinds of methodology. The last example about new kinds of nanomaterials for the solid phase extraction studies is nanodiamonds. Nanodiamonds are diamonds and whole size is the scale of 4 and 5 nanometers. Nanodiamonds have excellent mechanical and optical properties, high surface areas, and surface structure. They are also non-toxic, which makes them well suited to biomedical application. And also these methodologies these properties are very important for solid phase extraction studies. Also, we buy nanodiamonds from commercial source, then we oxidize it by using nitric and sulfuric acid, then we get its magnetic properties by adding iron compounds, then we have new materials. This material has magnetic properties and some active structures for solid phase extraction studies. The characterization is also performed by using infrared XRD studies is also important for this characterization of these kinds of materials. Same structure of materials, you can see it has very high surface area. Then we apply these materials for the determination of a pesticide, which is called ZIRAM, zinc bis dimethylcarbamatoate. It has like a carbamate pesticides used in the agricultural purposes. We use these materials for the absorption of ZIRAM from the water samples. Then we have a work about determination of ZIRAM in food and water samples. This is an example for these kinds of methodology for usage of carboxylated nanodiamonds. Then at the end, I have some collaboration and thanks, especially collaboration with King's South University is very important for me, especially Professor Zeyd El Othman is one of the wonderful colleagues for us, for me, and also Dr. Mohammed Habila, he is very important people, and also I have a lot of good friends, a lot of good colleagues at the King's South University. It was an honor for me, and also I have another collaboration with Brazil, Pakistan, Azerbaijan, Egypt, and also I have some collaboration from Turkish universities, also from Hacettepe University, Pamukkale University, and others. I want to thank all of them for their helps, and also funding is important for these kinds of works. I want to thank the Turkish Science Council, TÜBİTAK. I want to thank my university for these kinds of economical supports, and also I want to thank King's South University for their supports for this kind, for my studies. And also this is my research group. They are working at the Kayseri. I want to thank all of them. And also I have many colleagues, many postdoc students from abroad, especially Dr. Mohammed. I want to thank again Dr. Mohammed Habila and Dr. Ibrahim from King Saud University, Dr. Fahim and Dr. Hamid Sumaili from Jazan University, and they are very powerful workers for solid phase extraction studies, for separation and preconcentration studies. Then thanks again King Saud University, the College of Science, Department of Chemistry, and a special thanks to Dr. Zaid, Professor Dr. Zaid Olatman. He is a very, very powerful scientific man for me, and I want to thank Dr. Mohammed Habila again. And thanks for your attention. This is end of my lecture. If you have any question, I can answer your questions. Thank you very much.
Thank you, Dr. Mustafa. We have one question. What is the difference between nanoscience and nanotechnology, and when we can use both terms?
There isn't any difference. Firstly, nano-sized materials we synthesize, then we use them for nanotechnological purposes. Especially, I am especially working these nano-sized materials on solid phase extraction studies. But nanotechnology everywhere in our life.
Okay. Also, one question says, how can I choose between these adsorbent according to the matrix or the analyte?
Maybe in my lectures I will give a lot of examples about your question, but the main thing is your adsorbents should be selective, your analytes. And you should select new absorbents, or you should synthesize new absorbents according to your analytes. Maybe experience is very important at this point. Experience of the solid phase extraction studies.
Okay. What is the purpose of separation trace metals by nanotube?
Everyone can easily use these kinds of materials for solid phase extraction studies.
Nice.
Is it enough?
Those are the questions. Thank you, Doctor.
Thank you very much.
For your time, and thank you for everyone for your...
I want to thank all of attendance people. Thank you very much. Inshallah, see you at Riyadh next time.
إن شاء الله. Thank you, Doctor. نشكر لكم حضوركم وفي أمان الله.
السلام عليكم.